Okay, so we're starting with some practice on writing the constraint equations. So one of the things that you got to figure out is what is what. And I said X was going to be iPads. They're going to sell for $600, and you're going to get $50 of profit. Y is going to be styluses, and you're going to sell those at $100 each, and you're going to get $10 of profit on each of those. So you should be able to write an equation if I tell you the total amount of money that they took in. So on a certain day, they're selling these, and they took in $10,000. Then what's the equation for that? So those of you who are trying it at home, pause the video and take a minute and try to write these constraint equations. All right, Zeke, what's the equation that added up to 10,000? Nice. Now, the less than or equal to part, that could be argued, but a lot of times these will be inequalities like that. So I actually like that you added that in there. And we know if they collected $10,000 that they sold $10,000 worth of stuff. So this probably would have been phrased in a different way to make it less than or equal to 10,000. All right. Now, how about the Y? Can I just say, oh, wait, I'm going to give you one more piece of info. If I told you that they sold I sold a total of 20 items. That's another equation. Notice I didn't say 20 iPads, 20 items. Got a new equation now. All right. Who gets what I'm talking about with the new equation? All right. Dear King, what do you think? X plus Y, because those are the numbers of iPads and styluses, is equal to 20. And again, we might phrase this in a way that's like the most we can sell each day due to, like, I don't know, we don't have that many workers, or it's just too busy to sell more than this. The most we can sell is 120, and then we'd say less than or equal to 120. Go ahead and make it less than or equal to. Again, we could phrase it in a way such that it would be greater or equal. All right, so there's our two equations. What equation haven't we done yet? Sommerfeld. Soraya. What equation didn't I do yet? Yes, it's called the optimization equation. Can you do that one? Don't overthink it. It's about profit. I'll get you started. You get $50 profit.
50x.
There you go. Now, it isn't an equation until you say equals. And so, Eric, finish it off with actually make it an equation.
50x plus 10y equals
Since it's profit, P. Just P. We just have to say it equals something. And it equals P for profit. See, if you don't have that, you don't have an equation. You just have an expression. All right. Now, could you, in theory, graph these? The first thing you'd want to do is solve them for Y. Take a minute and solve both of them for Y. You can leave them like, not simplified perfectly. Just get it solved for Y. Get this solved for Y. But you don't ever solve the optimization equation. This is how it'll always look until you stick numbers into it. But you should be able to solve an equation for Y. That's an important skill, because that's how you're going to graph it. All right, so there's the writing of the equations. There's the solving of the equations, which is what you're working on right now. And then there's actually graphing them. Now, I don't want to graph this one because it's probably going to come out to some weird decimals because I didn't have it all set up perfectly. And I want to have you graph some simpler ones. The biggest things I want to make sure you're not doing wrong on graphing is I want to make sure you're remembering the solid lines versus the dotted lines and which way you shade, whether it's above or below. So we can do that with some easier graphs. All right, so this one, to solve it for y, you would have subtracted the 600x from both sides, and you would have had 100y is less than or equal to 10,000 minus 600x. Now, really what you ought to do is rearrange that and put this negative 600x first plus 10,000. I'm just flip-flopping them. Then I'm going to divide everything by 100. That'll cancel off a couple zeros here. And this will cancel off a couple zeros here. And it'll be y is less than or equal to negative 6x plus 100. Oh, that worked out really nice. Raise your hand if you had that one right. Okay, cool. What's the y-intercept then? 100. And what's negative 6 mean about the slope? Goes down 6 and over 1. Good. That's what I was talking about. All right. Now this one, to solve for y, super easy. Y less than or equal to negative x plus 20. Does that make sense? Okay. Now, to actually check your graphing part, let's just pull up, everybody bring up some graph paper onto your iPad. It's harder for me than it is for you because...
Can you just do it on dead mouse?
Nope.
Nope.
Nope. You're going to have to actually pull up some graph paper. It doesn't need to go forever. Just you have several boxes in both directions. And let's just graph simple ones, because if you can graph a simple one, you can graph them when the numbers are bigger. Would you just graph y equals negative 2x plus 5, and let's go less than or equal to. Then let's graph y is greater than or equal to 1, and x is less than or equal to 3. And then there's your common sense constraints, which I didn't talk about last time. Well, that's right. You were supposed to also have x is greater than or equal to 0 and y is greater than or equal to 0 in your list of equations. Easy to forget those, and I did. All right, back over to here. We're going to also include those. Can you graph that little tiny system of equations? There's at least one of them that's going to come out when you look at where the lines are crossing. One of them is going to cross at a decimal, and hopefully you'll be able to figure out what that is. All right. Did you figure out that dark green shaded in area is your feasible region? Now, I know mine's not perfect. Yours is on graph paper, so it's probably even better. I think that this line should be kind of like over a little bit further to the left, but where the tilt of the red line is definitely could be different. But you should have 3 key spots, that, and this spot right here, which frankly, the fact that it's not really easy to tell on my graph paper is good, because then I'll know, do I know how to take this blue line, y is less than or equal to 1, or sorry, greater than or equal to 1, and put it together with this red line, y is less than or equal to negative 2x plus 5. Do I know how to put those together and solve that system so I can figure out where they crossed? You get what I'm saying? Sometimes you're going to have a hard time looking at your graph and going, I don't know what that spot is. But I know it was this equation and this equation. Take those 2 equations and solve the system and figure out where they actually crossed. All right, if I was going to solve this system, I would see if anything would eliminate, and it will. I could do substitution, though. Actually, it'd probably be easier. It says y is 1. I could put a 1 right here and then solve it. And when you're solving these, you're trying to tell where they cross, and you don't have to worry about the shading. So therefore, you can just act like they're equal to. If that was bothering you, just think of it as y equals 1 and y equals this. And we'll see what x is after I stuck 1 in for the y. 1 equals negative 2x plus 5. Subtract 5 from both sides. Negative 4 equals negative 2x divided by negative 2 divided by negative 2. X equals 2. Cool. Looks like it actually worked out really nice. I thought it was a decimal. It wasn't even a decimal. Is that the exact point, y equals 2? No, that's the x of the point. Now the y of the point, I can go stick this into one of my equations. If I put, there's no x in this equation up at the top, so I don't use the blue equation, but I use the red one. And y is less than or equal to negative 2x plus 5. I stick the 2 in to that. So y, I'm just going to solve for equals to start with. And I get negative 4. And that's a 5 right there. Sorry, my handwriting was bad. Plus 5. Y is equal to 1. 2 comma 1. Now, do you get if that had been a decimal? This would have been the only way to get it. Because you're reading your graph. You can read your graph and it hits exactly. Yay. But it isn't always going to hit exactly. You got to know how to solve a system. All right. So now there's 3 key spots. 2 comma 1 is one of your key spots right here. This spot and this spot. To optimize and figure out what makes us the most profit, my gut says it's the thing that's the furthest away from the origin, but that's not always true. We make a lot of y's at this spot here, but we don't make any x's. So I bet I really need to compare them. So here's my 3 key spots. 0 comma 1, 2 comma 1, and this spot here, which is at 0 comma 5. Would you please list those 3 spots in a little table? And see which of them gives you the most profit. Now, we're going to use the same profit for this as we had over here. So we're going to use the optimization equation we had for this guy, which was x had $50 of profit, so 50x plus 10y. to get this to be an actual equation, I'm gonna say P equals 50x plus 10y. This one would be worth $50 because it's the 5 here times the 10. And then this one would be worth $10. And then this last one would be 50 times the x, which is 2 in this case. 2 times the 50 is 100 plus 10, 110. All right, so 2 comma 1 wins. You might have thought that this was the furthest from the origin and therefore the most profit. It actually wasn't because the y's weren't giving us much profit. It's true in the real world. You sell different products. Sometimes you have one product that's really profitable and another one where you don't make much money on it. All right, so there's another example. And we did pretty much everything there. We made equations, we graphed equations, we used the optimization equation to figure out which one had the most profit. Do you have any other, we've been doing this for about 17 minutes. Do you have any other questions that you want to ask about any part of the process, about writing the constraints or about graphing them or about figuring out which one has the most optimization process? Okay, then what we have is a review, and I want you to do 2 of them tonight, and then we'll save the last one, the third problem, for tomorrow. When I was expecting to give the test tomorrow, but again, a lot of people absent for testing, and it's just hard, and we decided we're going to give you an extra day to get ready. Okay, so today, work on problems 1 and 2. I really encourage you, but I'm not going to make you work in groups, but I encourage you to ask the kid next to you, hey, how are you doing this equation or whatever. Problems 1 and 2, and then save problem 3. Even if you could do it, please don't. Otherwise, you won't have anything to do for practice tomorrow. I do have one more problem that you're going to do as sort of like a little test in class. And there's one other one I can turn your attention to. There was one practice problem in the notes for yesterday, because I know there's going to be people that are going to want one more practice problem besides the one I give you tomorrow through the sub. But yesterday was Monday. You look in Monday's folder, there's something called notes and completed notes. If you look in Monday's folder, I never did those notes, and there's a whole practice problem there. And then the completed notes has the answer to the practice problem. So if you want another one to do for practice, there you go. In Monday's folder, the linear programming notes have a practice problem that I never did, and a key for it in the completed notes. All right, so there's a bunch of things you can do to practice. Now I want to give you a bunch of work time. And then tomorrow, you'll take that little practice test on one complete problem beginning to end. And then the test is actually Thursday. That's all I got for you for today.